Day one of our exponential functions unit. So we start off with understanding that exponential functions has the, it has the equation y equals a times b to the x. So what we end up doing, this, of course, this is just a review for you guys, so this should have been really easy for you. But we start with exploring exponential functions. So it asks you the question, which of the options below will make you the most money after 15 days? Do you think earning $1 a day will make you the most money, or earning a penny at the end of each day, and then or at the end of one day? So a penny would be this one, where I'd have a penny for this one, 2 for this one, 4 for the third day, 8 for the fourth day, and so on and so forth. And of course the above would have just been $1, and then 2, and then 3, and then 4. So what you end up learning with this is you learn that what's happened is they end up just going on. For A, you're doing 1 plus 1 will give you 2. And the same thing happens here. 2 plus 1 equals 3. So it's just increasing by 1. Okay, so it's adding a term or adding a number, a constant, in order to get to the next term. So that is just reminiscent of a linear function. Okay, so example A represents a linear function because I know I am adding to get to the next term. But with B, I'm actually multiplying because it's doubling every time, right? I'm doubling this, so I am multiplying. When I'm multiplying, it's not linear anymore. It won't create a straight line, of course, because linear creates that straight line, right? Because it's doubling and growing at such a fast pace, it's going to create that smooth curve, okay? The smooth curve that we know to be an exponential function. Okay, so when it's multiplying this way, you'll have an exponential function. Okay, you have a constant ratio when we're dealing with exponential functions. And again, we know it's exponential because we are multiplying. Okay, so next thing we have is, again, the general form of an exponential function is y equals a times b to the x, where a is your initial value, which of course is our y-intercept. And of course your y-intercept is where your graph crosses that y-axis. So it crosses here. Okay, so if you were looking at this example over to the right, that's our y-intercept. So if I had to say it, I would say that A is 1. Okay, and then B is your change. Of course, we also called B our ratio. When we talked in our previous unit last week, we talked about the ratio and the y-intercept. It's the exact same thing. Okay, in order to find that, you can always, if you're given 2 points, you can figure out the ratio by doing the second term divided by the first term. It'll always give you your ratio if you have an exponential function. Okay, you can also see that the difference between this exponential function and a linear function, where I would have had y equals mx plus b. The variable is in the exponent, of course, as you can see right here. It's in the exponent versus being a base like this. Okay, you also start really small and you increase very quickly, or vice versa. You can start really high and then decrease very quickly. We also have asymptotes, which we'll learn about what those are, but, well, it's right here actually. The graph heads towards a horizontal line, but it never actually touches it. And of course, we have constant ratios, where we're multiplying by that same number every time, which is what you just saw in that previous example. All right, so we're going to move on. You need to know how to evaluate exponential functions. So for exponential functions, the variable is in the exponent, but you still evaluate by plugging it in. By plugging in that value given. So I will do A and C with you, and you do B. All right, for A, it says f of x equals 2 times 3 to the x, where x is 5. This means wherever I see x, I'm going to put a 5 in its place. So f of 5 equals 2 times 3 to the 5th power. Okay, when I do that, I'm going to use my calculator off screen, of course. So I'll have 2 times 3 to the 5th power, and that gives me 486. This tells me that the 5th term, or that the 5th point here, whenever x is 5, my y value is going to be 486. Okay, so again, you will do B on your own, and then C, it says find f of 2. Again, this is exactly how I just wrote this one over here, right? So all this means when you see f of some kind of number, it just means that x equals whatever that number is, and our number is 2. So we're going to say f of 2 equals 4 times x, and of course our x is 2. And of course 4 to the 2nd power is 16. So I know when x equals 2, my y is 16. And I'm done there with both of those. Okay, and we're going to go ahead and move on. Alright, next up is graphing exponential functions. The general form of an exponential function is y equals a times b to the x. Again, this is just a reminder up there. An asymptote is a line that an exponential graph gets closer and closer to, but it never actually touches it. The equation for the line of an asymptote is always y equals 0. Okay, and it's going to be y equals 0 for us in IM1. Because we're not going to be doing anything fancy with these exponential functions. We're just kind of introducing them. And when you get into higher level maths, you might be transforming exponential functions where it might go up and down. It might even go left or right, and that'll change your asymptote. But we're not going to do that. All right, so moving on, I'll help you with this A, and then you guys will do your B on your own. Okay, because it's the exact same way. So again, since I know that the asymptote for us is always going to be y equals 0, I can go ahead and fill in this part in example A. And I can go ahead and do this. All right, so you can see that they say we need to graph the following: y equals 3 times 2 to the x. So what we're going to do is we're going to plug in our values for x in our table to find our y. So we'll have 3 times 2 to our x, and our x here is -2. All right, and that's going to give me 0.75. Okay, then I'm going to do the same exact thing here, but instead my x is now -1, which is 1.5. Same thing for 0. 3 times 2 to the 0 is just 3. 3 times 2 to the 1 is 6, and 3 times 2 to the 2nd is 12. I'm going to go ahead and graph that, and then I can answer the last couple questions that they asked me about growth or decay and the y-intercept. All right, so when I graph this, my points are really easy to see. So my first point would be -2, 0.75, and I wrote that really weird. -2, 0.75. So it's just the y value, the x comma y. Okay, x always comes first. Okay, so you can just do that, and I'm not going to write the rest of them. You totally can though, but it is there for you. So I'd have -2, 0.75, -1, and I will write it. Sorry, I changed my mind. -1, 1.5, 0,3. I'll put it down here. 1,6. And this one would be 2,12. And it's obviously off page, but I'll put it there. Okay, so with that in mind, I can go ahead. Again, I know that my asymptote is y equals 0. So I'm going to go ahead and draw a line where my y is 0, which is just the x-axis when y is 0. And I know that my graph of this function should not pass that line, and it shouldn't touch it. So I know that I have this function, right? It's doing this, and it has to turn. It has to. Okay, because it can't actually cross that line, and it can't touch it. So it gets as close as it possibly can. As close as it possibly can to that line without actually touching it. So this is our exponential function here. With this, now I can answer my last final questions. So first off, it asked me here, is it growth or is it growing or decaying? So you read graphs, you read them from left to right, just like how we read a book. From left to right, you answer the question, is my graph growing or is it decaying? So from left to right, it's getting bigger, right? It's going up. So I can say it is increasing. Since it's increasing, naturally, you're going to think that's growth, which it totally is. Okay, and if it was decreasing, it would be decaying. All right, and of course, our y-intercept is where our graph crosses that y-axis, which is here when y equals 3. Which again, you could have easily figured that out from your table here. Your y-intercept is always when x equals 0. So always remember that, because that'll save you some time. You don't always have to graph it to figure that out. Okay, it is when x equals 0. That's your y-intercept. Okay, so that was your guided practice for that one, and I believe we have a few practice problems on the next page. Yep. So I'm going to help you out with numbers 2, 4, and 5, and I want you to cross out number 7, and yeah, okay, I'm gonna help you out with those. All right, so again, they always have at the top the equation for you, so you don't have to keep remembering it, and that's good because on your EOC, which is our end of course test, you will have this formula with you, so you don't have to memorize it. It's perfectly fine. It's here. That we just won't have this when we have our test. Okay, so you have to remember that part, what A, B, X, and Y stand for. Okay, so for 2, I need to identify my A and my B in order to write my exponential functions, or they ask me for an equation, so I don't need to have the function part, I just need to have the y. Okay, so I know I'm going to have y equals something, right? Okay, so my A is my initial amount, right? My initial value, just like we just did on the previous page, is when x equals 0. Well, it's super easy for me to get back to 0 here. So when I'm looking for x to equal 0, I just need to say, okay, well, if x equals 0, I can go backwards 1, right? So can't I do the same thing for the y's? So I have to ask myself, well, how are they getting initially from 128 to 64? I'm dividing by 2. But for an exponential function, I always need to be multiplying, if you remember. Okay, we're always multiplying. So instead of saying I'm dividing by 2, which is not an actual number, just say I'm multiplying by a half. Okay? Because dividing by 2 is just is just taking half of that number. Okay, so I'm multiplying by a half. Whatever number you're multiplying is your ratio. Okay, that's our factor. So that is our ratio, which we'll eventually call it our factor on the next day of this lesson. So our B is a half. Our A we're going to find by doing the opposite of multiplying by a half, which is dividing by a half. Dividing by a half is just multiplying by 2. So I know that when x is 0, my y is 256. I did that by doing 128 times 256. I'm sorry, 128 times 2. And then I see that my y-intercept is 256. And I'm going to identify that here in a different color. That's my y-intercept. Since that's my y-intercept, that means my A is 256. Okay, so since I know A is 256 and B is a half, I'm going to go ahead and write my equation. All right, so y equals A, which is 256, times B, and I always put mine in parentheses because it makes it easier for me, times B, which is a half, to the power of x. And that is our final answer there. Perfect. All right, number 2. We can already identify our y-intercept. Again, your y-intercept is where your graph crosses the y-axis. Our graph crosses the y-axis at 0, 8. So when x is 0, what's our y? Our y is 8. Okay, so our y-intercept is 8. So that means that my A is 8. Okay? And let me not put that. I'm going to put my y-intercept. Okay, so I have my A identified. Now I need B. B is telling me how I got from one point to the next. So if you remember, we always read our graphs from left to right. So from left to right, which point comes first? I can see that 0, 8 is the first point and 1, 4 is the second point. So I'm trying to see how I get from 0, 8 to 1, 4. So I'm going to say 0, 8. And actually, I'm going to put it in a table because that's what we're familiar with. Okay, I'm going to have a table for my x and my y values, 0, 8 and 1, 4. So, of course, I'm just adding 1 there, so that's good. And here, I'm dividing by 4. So, okay, but remember, with exponential functions, I'm always multiplying. So, what number can I multiply 8 by to get 4? I can multiply it by a half. So, with that in mind, I know that my b is a half here. So finally, I can go ahead and write my equation as y equals a times b to the x. And I'm done with number 2. Okay, moving on to number 5. March Madness is an example of exponential decay. At each round of the tournament, only the winning teams stay. So the number of teams playing at each round is half the number of teams playing in the previous round. Okay, so it's saying each is half the number of teams playing in the previous round. So to get from one to the next, it's half, right? So they multiplied by half, which means our B is a half. They say 64 teams are a part of the official bracket at the start, okay? 64 are in the bracket at the start, which means that our initial value was 64. So they just told us the A is 64. And finally, they say how many teams are left after 5 rounds of play, all right? And if it's after 5 rounds of play, they're telling us, hey, find your Y, which is the number of teams in the bracket, after 5 rounds, which must be your X. So X is 5. So I've got the equation Y equals A times B to the X, so it should be 64 times a half to the X power. And again, our X, we were just told, is 5. So Y equals 64 times a half to the 5th power. This is when you put it in your calculator and you are able to find out that, let me see, times a half to them. All right, there are 2 teams remaining in that, or 2 teams left after 5 rounds of play. And that's our answer. Okay. All right. And again, you guys are left on this page with 1, 3, 6. I also wanted to remind you of, for 8, you're also left with 8. But I also wanted to remind you for 8 that since they asked write a function for the sequence, this is a geometric sequence. Of course, they have the a in there, and it's got to find out what they're multiplying by. But the formula for a geometric sequence is here, and it is an equals a1 times the ratio to the n minus 1. Okay, where a1 is your first term, r is the ratio, and of course n is whatever number you're trying to find. Okay, so that will help you with number 8. Moving on, you also had this where it asks you, you have these points that are on the graph, which equation represents that function. Okay, so all you need to do, whenever I see points, I automatically want to put it in a table, which is perfect. Okay, so let's go ahead and do that. We can have our x and our y. So we have 0, 1, 2, and 3 for our x's. I don't know why it took so much space. Okay. All right, we have that, and I will erase this part. Okay. And then for our y values, they gave us 1, 5, 25, and 125. Okay, so good. Let me move that up and make it a little bit smaller. Okay, so I got that. Okay, so we need to figure out one, again, if we're writing a function or a graph, or I'm sorry, a function or an equation, we always need to figure out what is our y-intercept and what is our ratio, okay, or our change. All right, so we need to identify A and B. So A is that y-intercept again. And again, I'm doing mine with you guys. Our y-intercept is when x equals 0. When x equals 0 in our table, our y is 1. That's our y-intercept. Okay, it's 1. So my A is 1. B is how I get from one number or one y value to the next. So I'm looking and I'm seeing, how do I get from 1 to 5? I'll multiply by 5. It should be a common ratio. So is 5 times 5 25? Yes. Is 25 times 5 125? Yes. So my common ratio, which is B, is 5. All right, and then lastly, I just need to make that into an equation, right? So my equation would have been A times B to the x, so y equals A times B to the x, so 1 times 5 to the x. If it's just a 1, it doesn't have to be there. It can just be an invisible 1. So I could actually convert this to y equals 5 to the x. All right, and if you want to make any equation into a function, just replace y with f of x. So I really have f of x equals 5x. And the option that matches that exactly is option D. Okay, so that was your answer for number 9. Okay. This next one I'm leaving for you guys, number 10. And that is it for day 1. All right, thank you.